Hello dear students, welcome to the chemistry online video class. This is Mohammad Asif Iqbal, senior teacher, Department of Chemistry, Milestone College. In this class, I will be discussing two of the creative question from chapter 5, chemical bond. This class will help you to understand what types of question there will be in your exam. So let's see what are the question. The first creative question, look at the stem. Here you can see three rows, element, period and group. Now come to the first one. Element A, which is actually a symbol, not real element, position in period 2 and group 16. Now come to the second question, element B, period 3 and group 2. And third element C, period 3 and group 16. Now come to the questions. What is valence electron? Number 2, explain that sulfur shows variable valency. Number 3, describe the bonding nature of compounds formed by element A and B given in the stem. So in this case, you have to be able to describe what kinds of compound formed by these two elements. Now students, come to the creative question 1D. You can see three vertical rows are provided in here. Element A, B, C, period 2, 3 and 3 and group 16, 2 and 16. Now come to the question. Analyze the number of lone pair electrons and bond pair electrons by using diagram of a compound formed by element A and C. You can see A and C, which period number is 2 and group number is 16, and for C period number is 3 and group number 16 mentioned in the stem. So here you need to mention how many lone pair electron and bond pair electron are present in the compound which formed by compound element A and C. Let's come to the first question. What is valence electron? The number of total electrons in the outermost principal energy level of an element is called the valence electrons of that element. So I repeat once again. The number of total electrons in the outermost principal energy level of an element is called the valence electrons of that element. So when we go through the electronic configuration of an element, we will find out how many electrons are present in the outermost principal energy shell. So I'm going to show you some of the example. You can see potassium. The total number of electrons present in potassium is 19. So when we go through the electronic configuration of potassium, we will find out that 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. So the last energy shell of potassium, the last outermost principal energy shell of potassium is 4, and the total number of electron here is 1. So the valence electron I write down in abbreviated form, valence electron is 1. Similar way, I would like to show you another example of valence electron. This is nitrogen. The total number of electron present in nitrogen is 7. So when you go through the electronic configuration of nitrogen, what we will find out? 1s2, 2s2, 1s2, 2s2 and 2p4. Now students, you can see the total number of the last energy shell of nitrogen is 2, and the total number of electron here 2 plus 4. So valence electron in this case is 2 plus 4, that means 6. So valence electron of nitrogen is 6. Similar way, I would like to show another example, which is chlorine. The total number of electron present in chlorine is 17. So when you go through the electronic configuration of chlorine, we will find out 1s2, 2s2, 2p6, 3s2 and 3p5. So the last principal energy shell or the outermost principal energy shell in case of chlorine is 3, and the total number of electron present in that energy shell is, you can see 2 plus 5, that means 7. So in case of nitrogen, the valence electron is 1. In case of potassium, the valence electron is 1. In case of nitrogen, the valence electron is 6, and in case of chlorine, the valence electron is 7. Come to the creative question 1. Question B. Explain that sulfur shows variable valency. Now, before go through the answer, first of all, we need to know what is actually variable valency. There are some elements which shows more than one valency during forming chemical bond with other elements. Showing more than one valency of an element is known as variable valency, and sulfur is an example which can show 3 different valency. So what are the 3 valency of sulfur? We know that sulfur show the valency 2, 4 and 6. So I'm going to give you the example where sulfur show valency 2, valency 4 and valency 6. So in the case of hydrogen sulfide, here you can see sulfur show valency 2 because we know that the valency of hydrogen is 1. And sulfur dioxide, you can see this is sulfur dioxide where sulfur show valency 4 because we know that the valency of oxygen is 2. So here what will happen actually, 2 multiply 2 is equal to 4. We know that the valency of hydrogen is 1 and 2, that means here sulfur show the valency 2. In case of sulfur trioxide, sulfur show valency 6. How we can measure that? We know that the valency of oxygen is 2 and 3 oxygen are present in here. So the valency of sulfur is 6. So in these 3 places, sulfur show 3 different valency. In hydrogen sulfide, sulfur show valency 2. In sulfur dioxide, sulfur show valency 4. And in sulfur trioxide, sulfur show valency 6. So why sulfur actually show different types of valency, or what is the reason behind that? Now students, if we go through the electronic configuration of sulfur, we will be able to understand more precisely. We can see sulfur, the total number of electron present in sulfur is 16. So when we go through the electronic configuration of sulfur, we will be able to observe 1s2, 2s2, 2p6 and 3s2 and 3p, 3p, 3p. According to the law of electronic configuration, there are 3 different orientation of p orbital. First one is px orbital, py orbital and pz orbital. So when the electronic configured in the sulfur atom, the first p orbital has 2 electron px and another 2 orbital has unpaired electron, and the valency is determined by how many unpaired electrons are present in the outermost principal energy shell. So in this case, sulfur show 2 unpaired electrons. So in this form, sulfur show valency 2. However, when sulfur get excited, what will happen? You can see that 1s2, 2s2 and 2p6, 3s2, we know that third energy shell, d orbital is present in third energy shell. So one electron is migrated from px orbital to pd orbital. So the electronic configuration become this. So in this case, sulfur able to show 4 valency because 4 unpaired electrons are present in the outermost principal energy shell. And in the third case, what will happen? We will observe. You can see students, when sulfur is extremely excited, the electronic configuration of sulfur become 1s2, 2s2, 2p6, 3s, 3p, 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 3d and 3d. xy, yz, x, y and z. So the one electron is migrated from 3s orbital to 3d orbital. So the number of unpaired electron present in this place, you can see 6. So the number of unpaired electron in the outermost principal energy shell of sulfur become 6. In this case, sulfur is able to show valency 6. So that is the reason behind the variable valency of sulfur. Now students, come to the creative question 1c. Here you can see 3 different rows are provided. In the first part you can see element, second period and third group, and two elements are provided in here, A and B, and their period is 2 and 3 and their group is 16 and 2. And now the question is, describe the bonding nature of compounds formed by element A and B given in the stem. Now you need to describe or explain what kinds of compound is formed between these two elements A and B. Now students, I am going to explain this question. You can see the board. First of all, the elements which belongs to the group 16 and period 2. So when we go through the electronic configuration of element A, what will you observe? 1, 2s, 2p. Because 2 is the period number, therefore the last electron remain in the second period, and the total number of electron present here is 16. So we can write down this, because according to the electronic configuration, when electron enter into the 6th energy shell or p energy shell, then we need to add with 10. So the electronic configuration of this element will be this, and we know that this element is actually oxygen. Oxygen has 8 electron at the outermost principal energy shell. So we can see oxygen has 8 electron and it has 6 electron at the outermost principal energy shell. Now come to the next element B. So I'm going to write down element B, and you can see the third period. So electronic configuration, when we go through the electronic configuration, what we will observe, the third energy shell, there are 2 electrons, so 2. So this is the electronic configuration of this element. So from the electronic configuration, we can find out that this element is magnesium, because it has 12 electron in its energy shell. So what will be it is magnesium. Now students, very important thing, what kinds of compound is formed between magnesium and oxygen? Very simple. Magnesium is a metal and oxygen is non-metal. And when metal and non-metal form chemical bond, that bond is ionic bond. So ionic bond is created between magnesium and oxygen. So what actually happened during in the chemical bond? Magnesium donate 2 electron to achieve the electronic configuration of neon. On the other hand, oxygen receive 2 electron to achieve the electronic configuration of neon. Therefore, what will happen? You can see magnesium will donate 2 electron and become magnesium ion, and oxygen will receive 2 electrons and become oxide ion. And then the chemical bond which is formed between magnesium and oxygen. So if we see what will happen on other form, you can see that magnesium, in the first energy shell, magnesium has 2 electrons. In the second energy shell, magnesium has 8 electrons, and magnesium will donate 2 electrons and become magnesium ion. On the other hand, what will happen? Oxygen has 2 energy shell. So in the first energy shell, oxygen has 2 electrons, and in the second energy shell, oxygen actually receive 2 electrons from magnesium, and that is why the electron become 8 and it become negatively charged. So there is a electrostatic attraction force created between these 2 ions, cation and anion, and a bond form which is known as ionic bond. Students, the compound is magnesium oxide. Now students, come to the creative question 1D. You can see element and their period and group number are provided in here. Element A, C, their period number is 2 and C consecutively, and group number is 16 and 16. In both cases, their group number is 16. Now question is, analyze the number of lone pair electrons and bond pair electrons by using diagram of a compound formed by element A and C mentioned in the stem. So we need to show a compound which is formed by these two elements A and C and show how many lone pair electron and bond pair electron are present in that compound. So I am going to explain this question. You can see the board. Students, here you can see in the previous question I discussed that element A is oxygen. Element A is oxygen, and in the second case element C, what it can be. We can see that both of the elements remain in the same group, group 16. The elements belongs to the group 16s are oxygen, sulfur, selenium, tellurium and polonium. So the C is actually sulfur. Now I am going to show you their electronic configuration. Number 1, oxygen. You can see 1s2, 2s2. We know that there are 3 p orbital x, y and z. 1. And in case of sulfur, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p, 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 x, y and z, and 3dxy 1. Now students, the question is what kinds of compound can be formed between these two elements. We know that oxygen and sulfur both are non-metal, and the compound which formed between two non-metal is a covalent bonded compound. So what compound it here formed is sulfur dioxide, which is a covalent bonded compound. Now students, how many bond pair electron and lone pair electron are present in sulfur dioxide? Before explaining that question, we need to know what is actually bond pair electron and what is actually lone pair electron. The lone pair electron is total number of paired electron present in the outermost principal energy shell. I repeat once again, total number of paired electron present in outermost principal energy shell. So you can see there are 2 paired electron present in the outermost principal energy shell of oxygen. So these are 2 lone pair electron. Similar way, in the sulfur there is 1 paired electron present in the outermost principal energy shell. So this is a lone pair electron of sulfur. Now come to the second one. What is actually bond pair electron? The number of unpaired electron present in the outermost principal energy shell is known as bond pair electron. So here we can see 2 bond pair electron are present in case of oxygen, and in case of sulfur there are 4 bond pair electron present. So why we are considering them as bond pair electron? Because they shared electron with other elements of this unpaired electron. So they use their outermost principal energy shell orbital and shared this electron with other electron to form chemical bond. Now in this case we can see in oxygen there is only 2 bond pair electron are present, lone pair electron are present, and in sulfur there is only 1 lone pair electron are present. So when we see the diagram of sulfur dioxide, you will find out that 5 lone pair electron are present in sulfur dioxide and 4 bond pair electrons. So where are these 5 electrons? You can see this is this and this. These are the lone pair electron which are not participating in chemical bond. We are not participating in chemical bond, but the bond pair electrons are there. This is bond pair electrons, and this is, so there are 4 bond pair electron, 1, 2, 3 and 4. That is how sulfur dioxide has 5 lone pair electron and 4 bond pair electron. We know that there are another kinds of compound can be formed between sulfur and oxygen, and that is sulfur trioxide, and that is sulfur trioxide. I would like to write down this in this place, sulfur trioxide. So what will happen in place of the sulfur trioxide and how this is actually formed? In this case, if we see the electronic configuration of sulfur, we will find out that 1s2, 2s2, 2p6, 3s, 3p, 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 3d and 3d. This is x, y, z, xy, yz. So the unpaired electron are bond pair electron are 1, 2, 3, 4, 5, 6. And in case of oxygen, what will happen? We know that the electronic configuration of oxygen one s2, 2s2, 2p, 2p and 2p, x, y, z. So here you can see 2 bond pair electron and 1 lone pair electron. Now if we see the diagram of sulfur trioxide, we will be able to understand how many bond pair electron and lone pair electron are present in sulfur trioxide. Now students, I am showing you how sulfur trioxide is formed. So this is sulfur and this is the first energy shell, second energy shell and third energy shell. In the first energy shell there are 2 electrons and in the second energy shell there are 8 electrons, and in the third energy shell we can see, so in this place what will happen, one oxygen atom will arrive and form chemical bond. In this place another oxygen, and in this place another oxygen. So how many electrons are there in oxygen? You can see now, you can see clearly. So in sulfur dioxide we can see that the total number of lone pair electron present in this compound is 1, 2, 3, 4, 5 and 6. So lone pair electron six. And how many bond pair electron are there? 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6. So the number of bond pair electron in sulfur trioxide electrons is also 6. So in case of sulfur trioxide, the total number of lone pair electrons is 6. This is the lone pair electrons, and bond pair electron 1, 2, 3, 4, 5 and 6. So number of bond pair electron is 6. Dear students, in this class I try my best to make you understand all the aspects and important question and answer. If you have any question or if you have anything difficulty to understand, please contact with your respective subject teacher. And thank you for being present from beginning to end.